Welcome back. In this class, we will discuss about what are the grand challenges in virtual reality and augmented reality. We are almost at the final stages of this course, and in this lecture, we will talk about we will summarize some of the topics we discussed in the earlier classes, and then see what is the challenges in the coming days. Specifically, we will focus on the most difficult concepts, uh, technical challenges in the virtual reality and augmented reality. Like the way we started in the first classes, the whole virtual reality depends on the two pillars like immersion and interaction. So, we will look at the grand challenges in the immersion first, and then later on the grand challenges in the interaction. And there are few other technical challenges other than this immersion and interactions. We will see them after this interaction and immersion challenges. Let us start with the immersion and grand challenges. We are talking about the immersion and we are talking about the interaction, and then we will talk about the other challenges. These are the three topics we will discuss today. We will start with the immersion. In the immersion, we are talking about either the visual immersion or the auditory immersion or the haptic immersion or the any other sensual immersions. Of course, visual immersion is the most important aspect of the virtual reality and augmented reality. We will initially see the visual immersion and then later on go into the other sensory immersions. As far as the visual immersion is concerned, one of the major challenge, we will talk about the visual immersion. One of the major technical challenge is the pixel density. We talked about in one of the earlier classes what is the required pixel density for the human not to see any of the digitization or pixelizations in the virtual reality displays, right. What is just enough? What is the enough pixel density? In one of the classes we talked about from the physiological limitations of the pixels, we derived some numbers, and then later on we talked about the limiting resolutions using the perceptions. For example, we looked at the contrast sensitive functions, using the contrast sensitive functions, and then we looked at we derived some numbers. For example, we talked about talked about some 10 pixels per mm is a current state, but what is required, it is about 80 pixels per mm, right. These are the numbers, some approximate numbers we got earlier. Okay. For example, we are talking about one of the latest display, one of the latest gadget, VR gadget in the market is called the Vive Pro, the professional Vive, which has got a display resolution something like 2880 cross 1600 pixels, is almost about 615 and dpi, or it's about 25 pixels per mm. Okay. So, our goal is to reach about 80 pixels per mm, whereas we are somewhere near 25. We probably it will take about another 5 years to get there. Okay. So, pixel density is one thing. The next major thing is the field of view. What is the necessary field of view? Again, the latest Vive Pro has a field of view about 110 degree, whereas as in one of the earlier classes we looked at it that we needed about 240 degree to give you the feeling of the immersion. Okay. And also there are some studies which says that field of view is very important to avoid the cyber sickness or motion sickness or all the other discomfort of the using the VR displays or AR displays. But there are some studies, very few studies which is saying and which has found that field of view does not really matter. Even those people with 240 degree of field of view, the user still gets the motion sickness or cyber sickness. There are few HMDs which have we are aiming at about 200 degree field of view or something like this. So, instead of going with a flat display, the few novel HMDs in the market, they they have the bend HMDs so that the field of view can be increased. So, the flat displays used in the HMDs can have very can have limited, but the same flat displays, if it is bent, then it can increase the field of view. There are few HMDs already available in the market. So, ideal full spherical field of view is going to be 360 degree cross 180 degree. Okay. So, that will be our aim to reach. That is going to be the challenge. Probably will take about another 10 years to reach to the stage. Okay. On the third challenge is the latency. Again, as we discussed in one of the earlier classes, the latency is that time lag between and the perception of the motion in the display from the time the user has actually moved. So, this latency, there are a few displays which are already in the markets have a latency about 20 to 30 milliseconds, which is not perceivable, but what is actually needed is 2 to 10 milliseconds, whereas Oculus, for example, has 20 to 30 milliseconds, and Vive has about 17 milliseconds. Gear VR has 20 milliseconds, and PS VR about 18 milliseconds. Okay. So, what we really want to do is aim at 2 to 10 milliseconds. There are the software techniques can be used in order to reduce this existing latency into the required latency. For example, Oculus uses some technique called asynchronous time warping. Asynchronous time warping. So, essentially we can estimate what is going to be the next frame and then render the frame ahead. Okay. So, this is to reduce the latency. So, this method is to pre-render an image before a scene hits the visual display. So that we can reduce the latency. There are few other techniques. Again, and what we need to achieve is 2 to 10 milliseconds. And then next challenge is to ensure the quality of the virtual content. So, the quality of the virtual content, again it means the number of polygons is the very crude measure, number of polygons, or the number of the graphics pipeline, right, the number of polygons that can be processed per second. There are NVIDIA graphics hardwares or AMD hardware which is specializing in virtual reality and augmented reality. Specifically, they have the SDKs, they have the hardware for virtual reality and AR. For example, NVIDIA has this VR Works, both now Unity and Unreal Engine supports the VR Works. We can use these VR Works, which is a hardware implemented in the NVIDIA graphics cards in the Unity, and then render many more polygons, and therefore you can increase the number of the quality of the virtual contents. Okay, number of frames is another number of frames per second. Frames per second is another crude measure of the quality of the virtual content. We are looking at least 50 to 100 frames per second. Again, and all this graphics hardware is going to help. AMD has now liquid VR. These are the SDKs, right. So, again, and liquid VR is supported in the Unity and Unreal Engine. You can also now download it and then start experimenting it. Okay. Then the third measure could be that the depth queue. It is very difficult to provide the information of the depth. The quality of the virtual content is really the 3D immersive environment. The 3D immersion comes because of the depth information. How well we can render the depth in the virtual environment is still a challenge for a lot of researchers, and what depth queue is used is still active research. So, depth perception is still an active research, and if the depth is not rendered properly, then the user will get cyber sickness very quickly, right. So, it will cause a lot of health effects, which we are going to see later. Okay. So, as far as the depth perception is concerned, I am going to emphasize another important point, which is still a grand challenge. I would call it as depth perception. In the depth perception, one of the most important grand challenge is called the Vergence accommodation recommendation conflict. This is called the VAC in the literature. There is a conflict between the vergence and accommodations. So, how are we going to solve this issue? That is one of the major issue, still it is being researched. Okay. And then fifth major challenge is that at aligning, let me say, aligning virtual content into the real environment with the real environment. So, this is where the AR comes into picture. How quickly the algorithms what we saw in the last videos about the extended Kalman filter, using extended Kalman filter, using the monocular SLAM or the visual SLAM or the SLAM in general, how accurately, how quickly we can align the virtual content with the real environment. In most of the situations, the scene doesn't have any features. The features in the sense, there are no edges, there are no sharp edges, there are no sharp corners, whereas the SLAM assumes that there are edges and corners. If the scene doesn't have any sharp edges, it is all very curved, very nice features, then feature extraction is going to be very extremely difficult. When there is no feature possible, then simultaneous localization and then mapping is going to be extremely difficult. It is still a challenge, it is still an active research as far as the AR is concerned, and for a general scenario where there are no edges and corners, what kind of other features, general features can be used for SLAM? It is still a challenge. Okay. So, that is about the visual immersion. Similarly, we have this auditory immersion. We are talking about how to provide the real immersion, auditory immersion, and in the virtual reality. Again, very high quality of HRDF is necessary for very good sound rendering, but this HRDF, which most of the 3D audio rendering algorithms are using, is for general user. It is all now average user, averaged from many users, let us say averaged from many users. But individual users will have a different HRDF, whereas this is for the general user. So, audio rendering with personalized HRDF is going to be the main challenge in the coming days. Okay. So, we do not know whether this is important, but in order to improve the immersion of auditory immersion effect, this may be important. Okay. Okay. So, similarly we can talk about the haptic immersion. So, the haptic immersion, again, in as we saw in earlier classes, is without the feeling of wearing heavy objects, we should be able to give the touch feedback. So, without adding inertia to the user or we need to render our force feedback. Okay. So, as of now there are gloves available, there are cyber gloves available which adds a lot of weight to the user's hand, therefore the inertia, and therefore it changes the feeling of immersion. So, ideally no, without any of these gadgets in the hand, and can we feel the force feedback? That is a challenge. How do we feel the force feedback? It is still a challenge. Most of the virtual reality without force feedback is not much useful. The user feel the realism is missing without the haptics feedback. So, the feeling of the virtual immersion and auditory immersion and the haptic immersion, it is all very important. There are recently Apple has come up with some SDKs, AR kit, which talks about specifically improving the visual immersion as well as the auditory immersion as well as the haptic immersions. You can take a look at it. Similarly, Google has also come up with another SDK called Google AR Core. So, if you are not aware of these things, and so I am going to request you to pause the video for a minute and then get yourself exposed to those kits, which may be very important and in the coming years. So, there you can see that in order to improve the immersion, there is a war between the major gains, software gains, and in order to come up with a better SDKs. Right? Okay. Apart from this, there is also recently there is also Magic Leap. So, Magic Leap is one of the AR glasses where it is much lighter than the HoloLens, Microsoft HoloLens, and it has a lot of other features, the special features. I think the specification itself is not out there, and again, and you can look forward to see advanced features in the Magic Leap. Okay. One of the very well talked about features of the Magic Leap is that if there are virtual objects in VR, in AR, and there are some real objects, it's in the there are real objects which is behind the virtual objects, or say in front of virtual objects in the AR, real objects. Then, and the occlusion does not usually happen, does not happen, whereas that is supposed to happen. So, Magic Leap says that they demonstrate that the virtual objects in front of or behind the real objects, the occlusion is taken care very well, whereas in the other kits, say AR kit or AR core, or that is not happening over here. And also it's Magic Leap is a very lightweight, and it is talking about okay. So, that's about the sorry, let me stop here. Okay, so that's about the immersion and challenges. Now let us look at the interaction challenges. Of course, the interactions we are talking about the haptic interactions. So, or the auditory interactions or the visual interactions. So, head tracking. So, head tracking is one thing. Head tracking, hand tracking, and objects tracking in the virtual reality. Object tracking. And then we are talking about the sound interactions, haptic interactions or sound interactions. Or sound interactions. So, in each of this we can talk about. The head tracking itself is a lot of challenge. The HMDs we are talking about has to be very light, right? As of now, the HMDs weighs much more than 1 kilogram, whereas if the HMD is more than 1 kilogram, we cannot wear this as for a long time. Even if you wear long time, you are getting used to the weight in your head, and when you come out of the virtual reality, you get cyber sickness. You get used to adapted to the adapted to having a lot of weight in your head. It is suggested that HMD weighs much less than 1 kilogram. In the future, all the big companies are running towards making this magic leap kind of devices. It's like a sunglasses. It should not be much more than the sunglasses, but still we should be able to render virtual objects into augmented reality. We should be able to experience this. That is the directions we are looking at it. As of now, the HMDs weigh 1 kg. So, imagine how much the sunglasses is weighing, how much is the current HMDs are weighing. That is a long way to go, right. Hand tracking, again hand tracking without any of the gadgets added to it is again a challenge, and there are techniques available, say leap motions or real sense, which is tracking the hands, but again reliably tracking is one of the important challenges. What is the accuracy of this hand tracking using this leap motions and other real sense is again the big challenge. How do we improve the accuracy of hand tracking? Not only hand tracking, even the finger tracking. Okay, so because in the virtual reality environment, it is not just moving around, it is not just navigation, and in the future there are many applications will come where the precise finger or hand movements is necessary, for example in the skills training. So, hand tracking, precise hand tracking is still one of the important challenges over here. Again, object tracking, there will be many objects in the real objects in the environment, and this objects should be tracked and the corresponding virtual object should be updated. Again, an accurate object tracking is important. So, Vive Tracker has solved this problem some way, but without adding inertia to the objects. For example, I have a very light object. In that light objects, we cannot put a virtual Vive tracker, which is itself is having more than a couple of 100 grams, right. So, if the object itself is 10 gram, if you add the Vive tracker, then it is killing the immersion object immersion of interacting with the objects. So, that is again the big challenges. As I mentioned, haptic interaction is going to be a big challenge without adding inertia to your hand, without adding extra gadgets to your hand. How do we give the force feedback? That is still a challenge. Okay. And then sound interaction also we talked about. So, speech recognition is still a challenge. Speech recognition. Most of the speech recognition engines and implemented in virtual reality or AR environment is trained using one particular user, but now it has to recognize as entirely new voice. Okay, so that is going to be the future challenge. If you have a lot of data, maybe now machine learning algorithm, much better machine learning algorithms can be used to recognize speeches of an entirely new user. That is going to be is still a research topic. Of course, we are talking about the eyes tracking also. Eyes tracking, the foveated rendering, and we talked about it in one of the earlier classes. Okay, locomotion, legs, and locomotion tracking. Locomotion tracking is again a big challenge. There are few gadgets or few products available which will lets you to walk around, and but still there are challenges over here. The gadgets are very big, but without adding much inertia to the legs or restricting your motion, how do we give a immersive effect of locomotion, and is a challenge. Okay, so you can see that there are many more interaction and challenges. Apart from these interaction challenges, there are other challenges. The other challenge is something like this: is how to let you build a virtual reality quickly. How to let you build VR systems, VR environments quickly or easily quickly. So, there are the Unities and Unreal engines which you are already aware of it. They are solving this problem. Their aim is to help you to build virtual reality systems quickly, but there are challenges. For example, if you look at the Unity, there are something is not possible. Okay. For example, soft objects, rendering soft object is still a challenge. Very simple soft objects you can render it, but now very complex soft objects which is necessary for some specialized applications is still a challenge. For example, soft objects. Interacting with the soft objects in the Unity, again it is going to be a challenge. Whereas Unreal engines, the soft objects may be possible, but there are other challenges in the Unreal engine. So, coming up with the SDK, Unity or Unreal engine like SDK, with a lot of features at the same time lets you build the virtual environment quickly is a challenge. Okay. So, it can restrict the features so that it can fasten the development, but having full features, many features at the same time, speeding up the development is still a challenge. So, that is where this Apple's AR kit and the AR core is AR core or AR kit. It is all helping you to build much better systems. Okay. So, one more challenge as far as the virtual reality or AR system is concerned is that the computer systems which is doing the number crunching, so much of number crunching along with the graphics card hardware, it has to be very, very small. Okay. So, right now only the desktops can do it. The augmented reality Microsoft HoloLens, which is bulky, can do only a little bit of number processing, number crunching, and in the future the whole device, the computer itself has to be very, very small. For example, recently HP has come up with the system called Z for VR and AR. So it's actually a VR backpack, actually backpack version. So the HP machine, the Z version of the HP machine can be put it into the backpack, and that system can be connected to your Oculus or Vive, which doesn't need it. Long wires to connect to the desktop, therefore it doesn't restrict the movement of the user. So development in the computational side is again a big challenge. How small computational systems and can be made to help the VR AR setup is still a challenge. Okay. And most importantly and finally, we are talking about the health effects. As far as the health effects is concerned in VR and AR, these effects are not completely known yet, So one of the most important health effect is the vection, the feeling of the illusion of self motion and illusion. Some virtual reality scenes or AR scenes will induce the motion of self motion, which is going to be causing the nausea or in total which is going to cause nausea, or in total it is called the cyber sickness. Okay. So all the health effects, we can call this as a direct effect. We can classify into either the direct effect or the indirect effect, and the direct effect or indirect effect. In the direct effect, we can talk about the effects to the eyes, the ears, and the hand and neck or the spine. All those details we can talk about. In the indirect effect, we can talk about after effects. We are talking about the after effects after using this virtual reality. So what are these problems? And then we can also talk about the social effects of the virtual reality and the augmented reality. So as far as the eye is concerned, so eye strain can be a major issue if you are using this virtual reality displays prolonged, and the flicker and the glare and the improper depth, they can all strain the eyes. Eye strain is one of the major challenges. So how do we ensure that a particular virtual content is not straining the eye of the particular user? That is still a challenge. Okay, poor illumination can be a problem. Poor contrast can be a problem. So eye strain is one of the major challenges. In fact, the radiation coming from the LEDs that can cause cataract. Okay, the effects are still not known, and the physiological effects is still not known, but there are possibilities. Okay. There are ocular symptoms, for example, unstable binocular vision or reduced visual acuity. These are all the problems that can cause into eye. Similarly, the ears also, there are some physical effects. For example, Walkman effect. If you are exposed to high volume of sound for a long time, then there is a loss of hearing. For example, more than 80 decibel if you are exposed to, then there is a chance of loss of hearing. Right. And if you are using the head mounted displays, which is heavier than 1 kg for a very long time, then there is a chance of neck and spine injury. There is a whole lot of there are a whole lot of effects known as cyber sickness. Of course, vection is one of the most important and cyber sickness. The headache or blurred vision or a combination of all those things, and there is a motion sickness. This also, the cyber sickness is also sometimes called as the motion sickness, as vection is one of the important things. How do we avoid vection? What kind of technology that can help us to avoid the vection is still a research topic, and then still we are still looking for solutions to avoid the vection in the virtual reality. Probably it will take another 5 to 10 years to come up with good solutions to avoid the vection. There is a conflict between the vestibular systems and the visual systems. How do we avoid this conflict? There are some systems which stimulate the vestibular systems whenever there is a self motion occurring. Okay. So, these are all invasive techniques which is again will have long term effects, its health effects which is not suggested. Okay. We are looking at the non-invasive techniques at the same time avoid the vection. Okay. That is still a challenge. Okay. As far as the after effects concerned, we are talking about the adaptations. So, if you are using the virtual reality for a very long time, then and you get adapted to it, when you are coming out of the virtual reality, you tend to continue feeling the virtual environments, for example motion. Okay. So, your brain is highly adaptive and it is highly plastic, but the advantage of or disadvantage of this plastic nature of your brain is that after prolonged use of the virtual reality, you still continue to feel as if you are in the virtual reality. Okay. It happens even for several hours. This after effects continue for several hours. Okay. So, how do we avoid this after effect is still a challenge. So, some of the effects is going to be head spinning or postural instability or reduced hand-eye coordination or vestibular disturbances. These are the after effects. Okay. And then finally, we will see what is the social effect. The social effects in the virtual environment, it is so stunning, the virtual content is so compelling, and what will be the effect of social effect of this very good highly quality virtual contents. Okay. If the user is practicing violence, say in a game of a shooting game, okay, how will it how will it help or worsen the psychological feelings of the user? What is the effect of virtual reality environment on the psychology of the user practicing violence? Or it can be used to improve the positive aspect, positive psychological effects of the user, such as cooperation or friendship or relation or love. These are the positive social effects of the virtual reality. So, it can either have the positive or negative effect. Any technology, it will have both positive and negative effect. But now what the social effect of the virtual reality is still not known. Probably we will take a couple of years to understand what is the social effect of this technologies. So, I hope I have given some overview of what are the grand technical challenges as far as the immersion is concerned and the interaction techniques are concerned, and we talked about a little bit other than the immersion and interaction techniques, and finally the health effects, specifically the social effects, the indirect effects, we looked at it. I hope some of you who are listening to these lectures will be able to address these challenges in the coming days and then make us proud. We will stop here. Thank you.